I work here in the Graduate School of Architecture, Planning, and Preservation. I actually studied there. I have a master's in urban planning and a master's in architecture. And what I wanted to show you today is one big project that I did some years ago, looking at Foursquare data, and then a series of very small projects looking at transportation in New York City, different modes of transportation in New York City. And the overall idea of the work is to visualize these very big and complex data sets and see what they tell us about the city. But at the same time, one way of doing things would be to analyze the data sets and then visualize your results, and that's perfectly valid and everything. But a lot of the work that we do is experimenting with different ways of visualizing, and through that experimentation, uncovering patterns that you wouldn't necessarily see in the first analysis. So I currently work at the Center for Spatial Research at the School of Architecture, but it was previously called the Spatial Information Design Lab. And the Spatial Information Design Lab is most famous for this project, which was the $1 million blocks. And the idea with this project was to look at incarceration data, where people who were incarcerated, where they were living before being incarcerated, and analyze if there were any concentrations of origins of incarcerated people. And what we discovered was that there were specific blocks in the city that were sending a lot of people to prison. So those were called $1 million blocks because it was costing the state more than $1 million to keep people in prison from those specific blocks. So the idea with this project was sort of to reverse it. What if we could invest that money into the community instead of into keeping people in prison, so that when they come out, they have resources, they have a network, they don't go back to prison, or even before that, so there is a network of resources in the community to prevent them from going to prison. We also collaborate, this is just a small introduction of the Spatial Information Design Lab, and then I'm going to introduce the center where I'm working now, and I'm going to move on to the projects. This is just a series of images of different projects we've been working with. We collaborate with people in the computer graphics department here at the university, trying to model hair for those Pixar movies for the animals. So those are very complex problems, and we help them a little bit sort of make algorithms more efficient for modeling hair. We also collaborated with Thomson Reuters, looking at shipping data across the globe, which is the image that you see there in the middle. You can't really see it, but there's a very interesting thing in that image. Those are GPS locations of oil tankers around the globe, and there's this space in the middle of the Atlantic Ocean that is totally black. So those are the things that you discover through visualization. This void in the map where you don't see any GPS signals, but you clearly know that the ships went through the middle of the ocean. So that sort of prompts new questions. What's happening there? Why are ships turning off their GPS signals? And it makes you explore the data set a little bit more. The one here at the bottom is actually pretty interesting. It was a project that was done looking at Weibo data, trying to visualize censorship in China. So a lot of people instead of submitting texts with information, what they do is they submit images with text because they're more difficult to read for computers, so they cannot be censored as fast and efficiently. And so what we were doing is downloading all of these images from a specific group of people and trying to find the images back again in the system, trying to figure out how fast they were being deleted. And we created a website where you can actually see how fast the images were spreading and how fast they were deleted. Okay, so now the Spatial Information Design Lab grew into a center. We got a nice grant from the Mellon Foundation, and the mandate from this grant is to work on architecture, urbanism, and the humanities. So before we were solely located in the architecture school, now we are collaborating with humanities professors, and we're teaching classes with 2 humanities students as well as architecture students. So that's been very interesting. We're also doing a couple of projects, a couple of big projects. The first one is this one, looking at data from Aleppo. we are building a platform where we combine multiple data sets of destruction and bombing of Aleppo, so data from UNISAT and VDC, which monitor conditions on the ground, but we're also looking at image recognition algorithms to detect rubble or destruction in the city. And through satellite images, we are visualizing change over time in Aleppo and trying to identify these places that have been destroyed. We built an online platform where you can play around with the data, you can play around with satellite images, and we're teaching a class based on these data sets. And this one is a project we're currently working on. You can not see that well. It's a map of Colombia, and what's showing is internal displacement in the country. Recently, Colombia is in the midst of a big peace process between the guerrillas and the government, and the government is collecting data about the victims of the conflict. So they've asked all the victims of the conflict to come forward and to register themselves in order to get reparations. And so far, they've gotten 7 million, almost 8 million victims registered. And one of the main crimes victims have suffered is displacement. So we're visualizing displacement around the country. It's an incredibly rich data set. It's an incredibly complex conflict. And the good thing is that a lot of people have talked about rural to urban migration, but here we can actually see it. We can see people leaving from very, very small rural towns going into the major cities over the last 30 years. So we can tie a lot of those lines. We can tie them with specific massacres or battles, or just with the conflict in general. So this is a project we're just starting to work on, and we're gonna look at displacement, homicides, kidnappings. We're gonna figure out if there are any concentrations of specific crimes around the country that can be correlated to different actors in the country, or if the government is allocating its resources in the right locations. Okay, so the first big project. This was a project I did with Sarah Williams. She was a professor here at the school in 2011, so it's a little bit old. And one day I was working with Sarah, and Sarah came to me and said, why don't we map Foursquare data? I had no idea what Foursquare was, what it was doing. Who doesn't know what Foursquare is? Okay, so Foursquare is a social media app where you check into places. You go to a restaurant and you say, I'm here, and all your friends can see that you're there. The people who check in the most become mayors of the place, and they get promotions. It seems a little stupid. When I was doing the project, I started using it, of course, and of course, after the project, I just stopped. It was very interesting, and this is sort of the whole point of the project. What can these social media data tell us about the city? Can it tell us something about the city, something useful? Or is it just data floating around? So what I'm going to do with this project is I'm going to go into how we build it, because I think it's an interesting process. And because we have a lot of open APIs where you can download data, I think you can actually learn a lot from this process, and it's still applicable into more current APIs. So on Foursquare, you can check in on your phone. We're looking at check-ins in Foursquare and in Facebook. I don't know if check-ins in Facebook are still a thing. I think they are still a thing? Yes? Okay. So those were the two services that we were looking at. Basically, what we had to do was write a script to contact the API. The API an API stands for Application Programming Interface, which is basically a little program that allows you to communicate with these services. It allows you to communicate with Twitter, allows you to communicate with Foursquare, Google. When you want to interact with these services, you want to write a program that interacts with the API and does something, submits a tweet or downloads directions. So we wrote a little script that contacted the API. You have to register, and you have to provide an authentication key, and then you submit coordinates. So you say, okay, tell me what venues are around this place and that place and that place. And the API responds with a list of venues. And then you have to, of course, clean up the data, organize it, and you can visualize it. So this was our first try. We created a grid of points over in New York City. This is 1,000 by 1,000 feet. And it was dense enough. That's what we thought at the beginning. And we submitted all of these points to the Foursquare API. This is how that grid of points looks around Union Square. So you see, there are points around the city. And this is the response of the venues that we got. Because Foursquare has a limit of 50 venues per request, it only gave us the 50 closest venues to the point. And you can see that there are a lot of venues missing there. It's super clustered. Our grid wasn't dense enough. So we created this 500 by 500 grid, which is pretty dense. Again, this is how it looks at the Union Square level. And this is what we got, which is much better, but it's still clustered. And so we created this grid, which is it's 250 by 250 feet. And this is how it looks at the level of Union Square, basically 1 point per block. And this is the grid that we finally used to get most of the venues. Now the problem is that this grid of points, it created 140,000 individual points. And an API, most APIs have limits because they don't want you just crushing their servers. And the Foursquare API had a limit of 5,000 requests per hour. So ideally, we wanted to submit 140,000 requests per hour to see over the course of 1 week all the check-ins that were happening. And so the only thing we could do it was by submitting it every 2 hours and by creating 30 fake accounts. So we went around and created 30 fake emails, 30 fake Foursquare accounts, 30 fake developer keys, and at that point we set up all the labs and all the computers in the lab to run queries on Foursquare for 1 week. The same thing happened with Facebook. We had 100 test users for our little apps, and this also creates a problem on the end. When you get all of these files, you're getting huge amounts of files from different users, from different accounts that then you have to merge, combine, clear all the duplicate venues, and process. Let me see if I can zoom in. This is how our response looked like back then. I think it still looks more or less the same. So you have the name of the venue, Starbucks, address, coordinates, categories, and then number of check-ins and a timestamp. So we would compare number of check-ins now with number of check-ins in 2 hours, so you can see the activity. And then we would combine all of the different files into one main data set. This is the raw response, Foursquare Facebook check-ins. And here, I want to pause a little bit. Here, when we first saw this, we thought, this is great. You can actually see streets. You can actually more or less see the grid. You can see parks. You can see a lot of the city just by the activity in social media. But the big question, or the big warning sign with using social media data for this kind of activity, is that social media data is hugely biased. It only collects data of the people who are participating in social media, who are most of the people who have access to smartphones, who are a specific demographics. Even though there have been a lot of studies that show how certain types of social media overrepresent certain minorities. So in certain cases, you're actually better off analyzing social media data than traditional data sets in certain cases. I haven't studied this, but from what I've talked to other people, apparently Instagram overrepresents Hispanics. So that's something interesting that you could look into if you want to study that specific demographic. In this case, it does provide a good overview of the city, but we always had to keep in mind that it is biased, so we cannot just treat this data as a representative sample of the population. This is the check-ins by category. So blue is shopping, yellow is food, the purple is nightlife. So you can actually see the distribution of the different categories around the city. And this is how it looks like at the level of Union Square again. So you can see that there are a lot of venues and there's a fair amount of activity. Then we proceeded to sort of explode the data and separate each category and create individual maps of the city based on categories. Home and work is on the left and nightlife is on the right. And this is just check-ins this is block group. At the same time when we were doing this project, the new census data came out. This was 2011. And so we wanted to figure out if there were any correlations between demographic factors and social media activity, or Foursquare and Facebook activity. So we mapped median age, household income, land value, and office and retail concentration, trying to figure out what demographic factors would be correlated with high levels of activity. We also map race. And there are much better maps of this, but one of the things that we saw when we were doing this is, again, how segregated New York is. And so we started doing correlations. The top one is median age. Are the census tracts that have specific median age, do they also have specific levels of activity? And we found that there was no correlation between median age and activity, which is, it's something that you would expect. But we didn't find any correlations. Median household income, there was no relationship between income and check-ins. Office and retail ratio, yes, there was a strong relationship, and that was pretty obvious. And average land value, there was a slight increase, but no significant correlation between check-ins and land value. Finally, we looked at race, and we saw that there were some correlations. Census tracts that had high percentage of white or Asian populations had usually more Foursquare and Facebook check-ins, and the inverse was happening with Hispanic or Black population. Then we mapped sort of the check-ins over the course of the week by category, and it's more or less what you would expect, except for this huge spike there. And this is something that we still don't have a concrete answer for this phenomenon. It's a spike in arts and entertainment on a Wednesday at 4 a.m. in the morning or 3 a.m. in the morning. And apparently there were 30,000 check-ins. So when we drilled down on it, there were 30,000 check-ins at Madison Square Garden at 3 a.m. in the morning. So you could say, okay, Madison Square Garden, maybe there was a huge concert, everybody was checking in, it was Katy Perry or something, I don't know. But no, there were no events at that time in that place. So our hypothesis right now, and this has not been confirmed by anybody, is that there was a server update at that moment. These companies, these services have millions of servers all around the world, all of them gathering data, and at some point they need to synchronize. And so we think that that synchronization happened at 3 a.m. in the morning on a Wednesday night. That's to say that you cannot trust this data completely. If you didn't visualize it like this, or if you weren't looking for these things, you would say, oh, there was a huge amount of activity. But you really have to be careful with social media data. Then we just created basic maps of New York with check-ins. Can you see that? Not really. This is sort of all the check-ins joined to the streets. So it's like an exploded map of streets by activity. And this is a topography map of Foursquare and Facebook. And here you can really see the differences between the two services. Foursquare is a little bit more even. It has more check-ins in Williamsburg, Brooklyn Heights. Facebook has more check-ins on Times Square, Yankee Stadium. So our working hypothesis is that Foursquare was more local, while Facebook was more touristy. But that's just a hypothesis. This was really interesting. I'll go into this. We got a group of interns to filter through the venues, and I started getting questions. It's like, hey, does the venue, my Bat Cave, does that really exist? So it's like, hold on, let me look it up. No, it did not exist. So we actually discovered that a lot of people were creating their own venues, fake venues, all around the city with specific geographic location. And we started filtering all of them out, and we created this map. I'm just going to zoom in. And oh, you can't read. Can you read? Yeah? So it's all over the place. You got Heaven and Hell's Kitchen, Hell, a lot of Heaven and Hells, a lot of Bat Caves and Hogwarts, and Pooper on the 3808 Hilton, Wake and Bake. What else is it? Den of Sin, Insanity. There are a lot of I want to commit suicide. There are a lot of I just met the love of my life. There are a lot of porn-related things. So there's a lot of complaints about AT&T or taxi drivers or cell phone signals. This was like a glimpse into the psychology of the people using the service in the city, which was very interesting. So it can provide this. It was a little bit of a throwback to the 1960s and 70s on how to experience cities in a different way. And then we went off and did the same process for different cities around the world. I really like this map. It's Tokyo, check-ins around Tokyo, because you can really see the transportation system and how the city is organized around commuter trains and those hubs of activity just by looking at social media. You can see the little train stations and how they concentrate all the activity in Tokyo. This is Moscow. Mexico City, you can see the big avenues and the big activity axis. Mumbai, which didn't have that much activity. Rio, and you can see the touristy spots. And Beijing, which really didn't have any activity. It could be because they use Weibo or something else. It could be because it's censored. It could be because, we don't know. Again, the point is every community treats social media differently. And so you need to be careful when you're using these data sets to extract information about cities and about how people live. Okay, so that was the big project. The rest is a series of small projects about transportation data, visualizing different modes of transportation, different issues in transportation, and sort of through visualization, analyzing and exploring the data. The first one, it was the first time I used the taxi data set. The taxis data set is very interesting for any of you who are working with transportation data or just big data in New York. New York makes available every taxi trip for the past 5 years is publicly available. There have been a lot of issues with privacy around those data sets. People have identified individual license plates and they have matched them to photographs of celebrities on specific days taking a cab. So you have a picture of, I don't know who, Kim Kardashian. No, she doesn't take cabs. I don't know, Jennifer Lopez taking a cab on 3rd Avenue, and you see the license plate of the cab. You can actually go into this, or you were able to go into this database, look for that cab, figure out what trip that was on that day, and follow her to her destination. That has been removed. Those identifiers have been removed, but there was a big issue around privacy. At one point, we were afraid that they were going to just scrape the whole data set and not publish anything else. They've continued to publish. They just scraped those identifiers, but it's a hugely rich data set, and it's very interesting to visualize it. So the first visualization and this was long ago, was this video that just shows taxis leaving from, this is Fashion Week, I think 2011. And you cannot see it, it's in 3D, and the elevation is based on the tip. So that guy, this one, got a huge tip. I think they were going to Newark. So right now it's totally flat, and the color is based on comparing their time, the time that that trip took, to what Google was predicting. So the reddish ones are the ones that took more time than Google. The bright yellow ones are the ones that did better than what Google was saying. Again, a very first attempt at visualizing the data, but you can see the parks, you can see the avenues, you can sort of see the bridges, you can see LaGuardia up there. So it was just a pure visualization. There was no analysis, but it was already very interesting. The next one had a little bit more analysis, which is this one. And the idea is that transportation systems in New York are not symmetrical. You take the subway to go to work, you walk, I'm just gonna pause it, let me explain. You walk to your restaurant, then walk back to work, take Citibike to a bar, and then take a cab back home. So the system is not like in many other cities where you drive to work and you drive back home. You're really using a lot of transportation modes, and that creates big asymmetries in the system. So we were looking at origins versus destinations. Here, the red means a lot of origins, blue means a lot of destinations, and they're going to sort of rise or sink based on the imbalance. And brightness, just for example, this bright spot, it means that there's a lot of activity, but it's pretty well balanced. So this is one day. It starts around midnight. That's Central Park. This is Lower Manhattan. A lot of people are leaving parties, going back home. Then it sort of dies. And then when people start waking up, you really see the imbalances in the city. You see Midtown becomes like this sinkhole. The music is a friend of mine. He saw the video and decided to write some eerie music to accompany it. And then again in the afternoon, this is around 2 p.m., the activity is pretty well balanced. In the afternoon, people start leaving Midtown, going downtown. They're leaving Midtown, going downtown, East Village, Soho. This is all taxi data, yes. It is, I think it's data, if I remember correctly, is data for 1 week in October, compressed into 1 day. Weekdays, this is not weekends, weekdays. So it's just compressing everything. And this was a grant with David King, who's a professor in urban planning here, and Jonathan Peters, he's a professor of urban planning and economics at Staten Island. And the funny thing is that every time they show this video, they say, oh, people love your video, because they go to very nerdy transportation conferences, and they say, oh, people love your video. It gets too much attention. It detracts from the paper that we wrote and the real analysis that we did, which is fine. Okay, so that was my first sort of encounter with taxi data. Then we went on to visualize more or less the same thing with Citibikes. And so, again, we created a series of animations. Let me start here. This is just overall activity. You can't really see how it's changing. This one. Yes, overall activity. And then I'm going to skip it because it doesn't work that well. Imbalance. So again, the blue is a lot of origins, the red is a lot of destinations. So this is how, through the course of a day, sort of the balance is shifting in the different neighborhoods in the city. It seems to be symmetrical, but again, it is not. And it could be sort of symmetrical over the course of one day, but at the specific peak hours, there is really no symmetry. A lot of stations are losing a lot of bikes, and they're becoming empty. A lot of stations are gaining a lot of bikes, and that's a big problem for Citibike, because then they have to start moving bikes around. And so it sort of defeats the whole purpose of the system when they have to take 100 bikes, load them onto a truck, and drag them through the streets, through, like in peak hour, through the traffic jams, to another station. There's no way, once peak hour starts, there's no way they can rebalance the system. So that's what we wanted to study. And so we wanted to visualize this imbalance in as many ways as we could. So again, simple maps. This one, every row is an individual station. Every column is 1 hour of the day. This is an average weekday in October. October is like the month that you choose because it doesn't have extreme temperatures. The people are not on vacation, so that's sort of your study area is October. And what's interesting about this visualization is that you can see the peak hours. You can see the two bright imbalance bands between 5 a.m. and 10 a.m. and between 3 p.m. and 8 p.m. And you can see how some stations start becoming imbalanced before others, how some of them stay pretty well balanced. And then we try to visualize this in different ways. Imbalance based on the actual activity, because it's very different when you have an imbalance of one bike because there was only one bike taken away, whereas an imbalance of 20 bikes because there's a lot of activity in those stations. And again, creating maps. And what's interesting here is that the stations that we're underlining there were stations that were pretty well balanced, even though they're in a hugely imbalanced areas. So what's happening around the stations? This is a question that was prompted. What is happening to keep them balanced, even though they're in an imbalanced area? And then we created these little dials for each of the stations that show the hours of the day and how much activity they had and what the balance was. So this one, First Avenue and East 44th, has a huge imbalance spike here, and then another one there. There are others that are more balanced. So again, multiple ways of visualizing the same data set. Another way of visualizing, I think this one is a little bit of a failure. It was an experiment. I sort of like it because it's ugly. This is a slightly different data set. We were asking every station every 2 minutes how many bikes they had. So this is every 2 minutes. And the red represents when the stations are almost empty, and the blue is when the stations are almost full. So those sort of the danger zones. And again, you can see the dead hours where nothing. This, for example, I think this is around 10 p.m. on a Wednesday. But you can also see the peak hours, and you can see how most of the system, most of the time, is in that sort of danger zone. Another way of visualizing is just through a line graph. This is one station, and I'm going to start overlaying more stations every 2 minutes until you get here, where you see how the stations stay most of the time either almost full or almost empty, and you have those peak hours where they go very fast from one to the other. That shows how difficult, once the peak hour starts, how difficult it is to keep the system balanced. Okay, so that was Citibike, trying to visualize balances and imbalances. We did a similar experiment with the Bay Area bike share system, which is a much smaller system. And these were we're sort of trying to create a little bit more artsy visualizations. So using, again, the same system of dials, This is activity over the course of a week. I'm going to zoom in so you can see it for every station. And this is the funny thing that happens, at least to me when I'm doing this work, is that I explore one type of visualization, then I want to do the same visualization for multiple data sets. And then I discover something else and I want to repeat it. And so it becomes sort of repetitive, but at the same time you're exploring different data sets through visualization. So that was activity over the course of the week. This is percentage of trips by day of the week. Origins versus destinations. This is the imbalance part. Here you can see that overall the system is pretty well balanced except for some stations. And percentage of trips taken by subscribers versus people who are just paying for the day. Okay, and finally, and I'm going to end with this project, we were looking, again, we're going back to the taxi data. And we weren't really looking for this, but we visualized payment method, looking at the green cabs and at the yellow cabs. And we saw that huge division between payments in cash, which are the yellow ones, and payments in credit card, which are the blue ones. And that immediately prompted a million questions that we tried to answer through visualization and through a paper. In the end, we found that there is a very strong correlation between payments in cash and the percentage of unbanked population in New York City. So the people who don't have access to bank accounts, which is highly correlated to minorities, not so much to income level, but minorities and I think immigration, when they came. And this is very relevant now because you have companies like Uber saying, oh, we want to be the providers of these services. But again, you're forgetting that only certain people have access to Uber. And you have a lot of people who are still relying on traditional transportation methods and paying in cash. So these are the green cabs, destinations for the green cabs. Again, yellow is cash hotspots and blue is credit card hotspots. The origins for the green cabs. Now, for those of you who don't know, does everybody know what a green cab is and how they work in the city? Okay, so you understand why there are no origins in Manhattan. Okay, or below 110 and 96. But you still see, even for origins, you still see the specific hotspots. Columbia University is a hotspot for credit cards, even though it's close to a big hotspot for cash. And this is the same for yellow cabs. This is for destination. You still have that big divide, maybe not as clear on the cash side, but the credit card concentration is very clear. And for origins, you still have the same divide. So this is the data set that we're now exploring the most. We're looking at green cabs and seeing how, one, they have affected the yellow cabs, the behavior of the yellow cabs. Are the yellow cabs moving further up because they're noticing that there's a market up there? But also we're looking at the green cabs and the fact that they cannot pick up anybody below 96 or below 110 or in the airports is generating a lot of empty trips. So we're trying to quantify that, that travel time where you're putting empty cars on the street. Maybe it's a good thing because you're providing service to a lot of people that do need it and that didn't have it before. But we need to know how much time and fuel is being wasted and how much congestion is being generated. This was my last slide. I can go into another project or I can answer questions. Project or questions? Anybody? Questions? All right, let's go for questions. Yes.
It's just about data that it's become that much more difficult to figure out the day of the life of the cab so that you can actually figure out.
Yes.
If they're
Yeah.
Is there any hope to get that back or a way to?
No, I don't think we're going to get those specific identifiers. So just for context, there was a couple of very good visualizations tracking individual cabs throughout the city. And that was done with the data set that had the individual identifiers. I don't think we're going to get that back at all. We have that data set because we downloaded it at that moment, but the new data sets that are available on the website do not have those identifiers, which honestly, for research purposes, it was great to have that because you could really track an individual cab and see behaviors. How do certain cab drivers behave? Are there any groups of cab drivers that only go to airports? Are there any cab drivers that only stay downtown? So you could really look at behaviors. But that generated a lot of problems with privacy. Some people were trying to identify Muslim cab drivers because they would pause at specific times of the day to pray, which is really, we shouldn't really be looking.
I see from a practical point though, for most immigrants, right? And my dad and I was a cab driver at one point. Knowing today, should I drive a cab? Should I drive Uber? Should I drive Lyft? Because each one of those presents a different type of income at the end of my day, based on conditions of month, weather.
Yes, you could do that analysis with the identifiers because you could track, oh, this guy made this much money. You could definitely do it. You cannot do it anymore today. And I think in the end, even though we lost that capacity, the privacy concerns were very strong. This slide is taxi, it's either origins or destinations, and I just put it there at the end just to show that even though that data is very precise and very rich, it's not that precise. You have a lot of taxi trips starting, like if you go to Midtown, they start in the middle of buildings. And so there's a level at which that data is not that precise anymore. Yeah.
About the Citibike project, you mentioned that there was one visualization which was you tracked every 2 minutes
Yes.
how many bikes were driving to the station. How do you track data like that?
So Citibike has an API where it's refreshed every 2 minutes, and it says for this station there are these many bikes, for this station there are these many bikes, and so every 2 minutes we were querying the API and getting data. And that's another case where after 2 weeks of every 2 minutes, you have, even though the data files are very small, you have this, your computer is filled up. So you need to learn how to deal with huge amounts of data. Yeah.
About in the different cities, the check-ins that what is your source? Is it Foursquare?
All of those are Foursquare, yes.
Foursquare and Facebook, and they get access to data from different cities?
Foursquare opens their API, and this is a little pitch for tomorrow. For those of you who are interested in learning how to query APIs, I'm giving a workshop in this same conference on how to query APIs through Python. So yes, Foursquare has an open API. Most of those services are interested in you building something to interact with them. So that's why they created APIs. That's why they allow you to post things on Twitter through an API, to download Twitter information through the API, just to make it more popular. There was a question in the back? No, geez. Yeah.
Yeah, so you're showing everything here in time, and I was wondering, did you look at things in terms of the frequency domain, and was the choice to show things in time just because it's easier to the audience to visualize what that means, or was it really that signals were easier to identify in time versus frequency?
What do you mean?
Like looking at like the frequency at which bikes were deposited into stations versus just looking at things in hours of the day.
I understand. I think it was, to be honest, because it was the first thing we thought of. It's like the obvious choice. But I totally understand that going one step further and looking at, and if I'm getting your question right, if there were like dumps of bikes, like 20 bikes at one point, that would be very interesting. And that's actually how you identify the rebalancing. When you see that a station goes in a 2-minute interval from totally empty to totally full, that usually is a rebalance. Citibike got there with a truck and parked 20 bikes there. Yes, but that would be the next step. Yeah.
So I have a kind of question. So this is like I see the amazing practical application of this. But do you think that you can use it to explore basic patterns of human societies? Because I look at people who want to do any problem. There are all these like continually tracking efforts to explore how social structures in other animals resemble very much because of the data. So I wonder if you could take aspects of your data and do like border comparisons to infer whether there are kind of fundamental aspects of variables in what you see and haven't kind of much weight on.
Yes, definitely. You can definitely do it. We haven't done it. There is a group out of UCL led by Michael Batty, who's been playing around with physics and biology-based algorithms to model how cities work. And they model crowds, for example, how crowds exit a stadium after a concert in order to predict where the choke points would be, or where, or crowds in the pilgrimage to Mecca, how crowds behave. And that's all based either on computer self-generating algorithms or animals or physics. But yes, you can definitely play around with that. We haven't. Yeah. All right. I have to stop. Thank you very much.